Hi there, I'm Dr. Adam Rondinoni. I'm a senior scientist at the Oak Ridge National Laboratory Center for Nanophase Materials Sciences. Well, kids love fidget spinners and kids love science. And so we're going to do a little science demonstration today, and we're going to make the world's smallest fidget spinner. The Center for Nanophase Materials Sciences is a Department of Energy user facility, which means our job is to offer cutting-edge experiments, instrumentation, and scientists to help other scientists do the science they need to do. That includes companies and universities. The instrument we're going to use today is called a nanoscribe. It's one of the cutting-edge tools that we offer to people who want to come here and do science. We're here in our clean room today. The clean room is a place where there's no dust, and that's important because dust can interfere with the processes that we use to make these very small machines and devices. Now, the nanoscribe is a special tool that takes liquid and converts that liquid to a solid only where we want to convert it. And in that way, it allows us to 3D print very, very small devices using a convergent laser inside of a liquid. And then we wash away the liquid and we're left with the device. Here's how we make a fidget spinner. First, our engineers draw up a design using a computer. This is called computer-aided design, or CAD. Then the CAD file is loaded onto the instrument where the design gets sliced up into manageable layers. And when all the slices are put together, it actually builds the device. Next, our engineer takes and adds a little bit of liquid onto a piece of silicon wafer, and that piece of wafer is loaded into the nanoscribe. The nanoscribe uses a laser that's focused, and only at the focal point where the laser is at its strongest does the liquid convert into a solid. Now, the instrument takes that laser and it rasters it through the liquid, much like a 3D printer rasters a squirt nozzle extruding polymer. But in this case, the laser converts the liquid to a solid. Once the process is complete, then the fidget spinner, still on the wafer, is removed, developed, and rinsed. Here are some scanning electron micrographs of the finished spinner. We can't spin it here in the electron microscope, so we'll put it on an optical microscope and blow on it with compressed air. This fidget spinner, from side to side, it's the width of a human hair. We think it's probably the smallest ever made. So while the fidget spinner is fun, most of the time we're using these instruments to do real science, where we're making very small machines, microfluidic channels, sensors, photosensors and such, for actual scientific purposes. The Center for Nanophase Materials Sciences is a user facility, which means everything that we have and all of our staff are available to other scientists that want to come here and work. So, if you want to do an experiment to be published in the open literature, then please visit our website at www.cnms.ornl.gov.